Hi friends, welcome to my channel. So in this channel, this is my first video, and this video consists in a lecture series which will focus on lead code hard problems. So here we will use iterative solution, and there is a solution which uses two stacks for iterative solution, but we will use one stack, and we will try to solve it. So first of all, what is post-order traversal? So uh, post-order first traverse to the left subtree, then right subtree, and then root. So here, as you can see, left subtree is no left subtree of root, so it will go to the right subtree, and in the right there is a left, so 3, then there is no right, so then root 2, and then root 1. So this is basically the post order traversal. So and in this lecture series I will use C++ to solve the problem. Yeah, so our basic idea will be we are going to use one stack, and in that stack, what will we do? We try to traverse leftmost part of the tree, and while traversing leftmost part, we put the root right child and the root in the stack, and on reaching the leftmost node, we will print a node if we don't have a right child, and if it have a right child, then we will process the right child first. So yeah, let's start to solve the problem. So as the return type is a vector of int, we will declare a vector of type int. We name it as a post order. First we will use the boundary condition that if there is no root or root is equal to null, then we will just return the empty vector. Then as I have told you that we are going to use a stack, so we'll use a stack, and the data type that we are pushing in the stack will be of type pointer to the node. We are not using the data because multiple nodes in the tree can have the same value, so we'll use the pointer to the node. And I am also taking one extra pointer to just have the current, which is right now root for traversing. So yeah, so we will traverse to the tree until the current node, there is something in the current node or there is something in the stack. So while this current is present and stack is not empty, so not the and condition or condition, any of them if is true, we will iterate. Now we have to traverse to the leftmost part of the tree, so we are using a iteration from the current, and if there is a right child of the current, we will push in the stack, and after pushing the right child, we will also push the current node. And as we want to iterate through the left part of subtree, we will set the current to the left child of the current. Now as we reach the dead end in the left side, so we will pop one from the stack. So in C++, the top is the command to get the top element, and then we will pop out that element. Then we have to check for printing, like as I earlier mentioned, that if we have to print that element if it is not the right child, if it has not the right child. So how will we can that do that? Like we will check whether right child exists or not. First we have to make sure this condition, then we will also make that the stack is empty or not, because there should be some value in a stack to check whether the uh, current right child it is same as the top element of the stack. So if a stack is not empty, we can check whether the right element of the current is same as the top element of the stack. If it is same, then we need to process the right subtree, right? So what will we do? We pop the that element from stack, that is basically the right child. So then we will push the current, because in post order we have to first traverse the right before the root. So in a stack we will first push the current, then we will move to the right. So now we have to traverse to the right, so we will set the current as the right child of the current. Else if this is not the condition, then we have to print the element. So basically we have to push the element in the vector we have declared as a post order. So we will push back the element. uh, so here we have to push the value of the current node. So we push the value, and then we set the current as null, so that we will pick another element from the stack in the next iteration. Now, so after this whole iteration exit, we have to just return the vector that we have created during the traversal. Yeah, so we can try to run the code, whether it's working or not, or there is some issue. Yeah, so as expected, the result is coming perfectly fine. So we try to submit the code. Yeah, as you can see, the memory, it is very memory efficient, because we are using a one stack uh, thing, and it is accepted. Yeah, so uh, for summarizing this, what we have done until now, we have created a stack, and we try to traverse the tree from the left side, and try to insert the right child and the current node. So for this is the part that we first push the right child of the current node, then push the current node, then we are iterating to the left side. When we reach the left dead end, leftmost node, we pop that element, and we check whether the popped element have any right child or not. If that have a right child, then whether it's same as the top element or not. So if it is the case, then we have to process the right child. So we will pop the right child, and we will push the current node in the stack, and we will iterate through the uh, right subtree. And if this is not the condition, we will just push back the value in the vector, and after this execution we return the vector. I think you have enjoyed the video. If you have any doubt, you can post in the comment. Yeah, thanks.